Hello everyone, my name is Qiulin Zhang. I'm from Florida International University and my pencil ID is 6028543, and this is my topic presentation for the Principles of Database Management Systems class. And today I want to present a paper. The topic of the paper is a comparison of approaches to large-scale data analysis. This paper was published in 2009, and there are following authors for this paper. There are many different ways to approach a large-scale database analysis. This paper focuses on the MapReduce and the parallel database management systems. They want to make sure which one is better when we use this, when we use that one. And so for the constant, there are 4 parts of this paper. The first is to introduce what is a MapReduce and what is a parallel database management systems. And the second part is to set the performance benchmarks. So the third part is going to do the analytical tasks. And the final part of this paper is the discussion of this result and the comparison and the disadvantages and advantages of these 2 different systems. So let's go to the first part, MapReduce and the parallel DBMS. So first is an introduction to the MapReduce. The MapReduce is really a simple systems. A MapReduce program consists only 2 functions. We can see the pseudocode. One is a map and one is a reduce. And these are written by a user to process key or value data pairs. And this input data set is stored in a collection of partitions in a distributed file systems and deployed on each node in the cluster. The program is then injected into a distributed processing framework and executed in a manner to be described. The paper also gave us some small examples of the MapReduce, how the map works and how the reduce works. And the parallel DBMS, as we all familiar with that, this seeks to improve performance through parallelizations of various operations, such as data loading, indexing, and query evaluations. And also data may be stored in a distributed fashion. In such a system, the distribution is governed only performance considerations. And the parallel database improves processing and input-output speed by using multiple CPUs and disks in parallel. So there are some differences between the parallel DBMS and the MapReduce. So first, for the schema spot, the parallel DBMS requires data to fit into the relational paradigm of rows and columns. In contrast, the MapReduce, the model does not require. The MapReduce programmer is free to structure their data in any manner. So the MapReduce is more open and more easy. And for the indexing, all modern DBMS systems use hash or B-trace index to accelerate access to data. And the MapReduce model is so simple. MapReduce frameworks do not provide built-in indexes. And for the programming model, the parallel DBMS is starting what you want with the SQL language, and the MapReduce is presenting an algorithm. You can use many languages like C, C++, and Java. And the parallel DBMS is also could could do well with optimizations, while the MapReduce is not. But as MapReduce is really simple, it's better for the flexibility and the fault tolerance than the parallel DBMS. So the second part of the paper is to set the performance benchmarks. The first task, the environment of this benchmark, there are two systems to test the performance. The first one is a Hadoop. The Hadoop is the most popular open source MapReduce implementation. And the DBMS-X, this is a parallel DBMS that stores data in a row-based format. And the Vertica is a column-based parallel DBMS. So we found different ways of the parallel DBMS and compare with the MapReduce based Hadoop. So I think this systems works good for the test the performance, and as for the node configuration, all three systems were deployed on a 100 node cluster, and there are 5 total analytical tasks. First is a data loading, and then selection task, aggregation task, joint task, and finally is a UDF aggregation task. So the first benchmark task is called grip task. This is each system must scan through a data set of 100 byte records looking for 3 characters, a pattern, and for each system, I created the grip tasks on cluster sets of different nodes. Here are the here are the results of the grip test of these 3 systems. We can see that the time of loading the data from the node's local file into each system's internal storage representation, as the amount of the data increasing from the the results show that the Hadoop clearly outperforms than both DBMS-X and the Vertical, since that each node is simply copying each data file from the local disk into the local HDFS instance, and then distributing 2 replicates to other nodes in other cluster. And as for the task accuracy, a pattern search for a particular field is simply the following query in the SQL. It's a select from data where the field is like XYZ. The results show that the Hadoop and the DBMS performs just similar, and the Vertica performs better than these two. So after this basic benchmark test, we go into the analytical task. So how to set the analytical tasks? There are tests that are more sort of outline for a database system. They pick a very simple processing schema so that the data looks like, first of all, a collection of the documents. These are just meant to represent HTML documents, and there are about 600,000 documents per node in this case. The document consists of a URL on the character string and then blob of text, and each machines have about each node in about 155 million user visits on it represents about 20 gigabytes per node of per node of the data. So the first task is data loading. The paper didn't talk much more about this because the performance is really very similar to what happens in the grep. The Hadoop performs better than others two systems. And the task 2 is a selection task. The selection task is a lightweighted filter to find the page URLs in the ranking table, which is 1 GB per node, with a page rank above the user-defined threshold. The query here is really simple. It's select page URL, page rank from this table from the ranking table where the page rank is greater than X. So from the results, we can see that the primary DBMS are better. The both Vertica and the DBMS is performance better than the Hadoop. The reason is Hadoop's increased startup cost as more nodes are added to the cluster, which takes up a longer fraction of the total query time for the short-running queries. And another reason is that parallel database management systems use an index, so executing this query is trivial. The third task is aggregation task. Aggregation task is calculating the total the revenue guaranteed for each source IP in the user visit, which is 20 GB per node, and is grouped by the source IP column. And the query here is select some source IP and the sum add revenue from this table grouped by the source IP. So from the results, we can get the conclusion that the parallel also performs better than the Hadoop. So it seems just like the selection result because the parallel DBMS is non-pricing overhead and is compression to the database. So another task which is the biggest performance difference is a join task. We can see that the Hadoop performs really bad in this task. The MapReduce program has to perform a complete table scan, where the parallel database systems are able to take advantages of consolidate index to reduce the amount of the data that need to be read. So we can see that the index really improved the performance of the database analyze. So it's a similar reason why the Hadoop performs worse than these two different systems. And another reason is that both the user visits and the rankings tables are partitioned by the join key. Both of them are able to do the join locally on each node without any network overhead of repartitioning before the join. And the last task is UDF aggregation tasks. This task is to compute the in-link count for each document in the dataset. The query is here. It's a select into the F and from this table, and it's also an easy query. The result shows here the figure 10. We can see that both DBMS X and the Hadoop have similar constant performance for these tasks. It's not that big difference than the formal tasks, and the DBMS X performance worse than the Hadoop due to the added overhead of the row-by-row interaction between the UDF and the input files stored outside of the database, and the Vertica's poor performance is a result of having to parse data outside of the database management system, and the materialize and the intermediate result on the local disk before it can load into the system. So after these 5 analytical tests, we can go to the discussion part. So we can know that for the database management, the large-scale database management, the Hadoop is much more easier to set up, and Hadoop load times are faster. But the MapReduce Hadoop is also have some weakness. The query times are a lot of slower because they don't have parsing or indexing, and they're not compression database, and it's a executional model. So when we choose the MapReduce, so I think the MapReduce is designed for one-off processing. The paper gives some answers. The MapReduce is designed for one-off processing when fast load times are important, so that when we need the fast load times, we need the MapReduce to do it faster, and it's no repeatable access. As such, lack of schema, lack of indexing. So if indexing works better, so we can choose a DBMS, and if it's lack of indexing, the MapReduce is better. And however, the authors also argue that is no compelling reason to choose MapReduce over a database for traditional database workloads. So after the analyze and after the test, the author gives the conclusion. The conclusion of the paper is that MapReduce and the database systems fill different reaches. So MapReduce is focused on the one-off processing, and database is better for the repeatable reaccess. And the advantages of the MapReduce is the following. First is easy to use, and it's an out-of-box experience. And this is a single programming language, and it's also aggressive fault tolerance properties, and it has a fast load times. Another is that the database advantages is that it has fast query times due to the indexing and compression, and there are many supporting tools to improve the performance of the database. So, but as far as I'm concerned of this paper, I think overall this is a really good paper that did a good job and making me to know the usage of the MapReduce, and to show that it's not always a good thing, it's a better choice for the database. However, I think this paper also missed some part. While the paper keeps pointing out that parallel DBMS is an older and more establishable concept, it's not always the case to why it outperforms MapReduce. As a matter of the fact, I googled that the Vertica used the C-store architecture, which could be considered a quite new, not to maintain a radical approach to the word traditional DBMS. The storage and the logical concept of the C-store difference from the role-oriented DBMS. In this paper, they use a DBMS X. I think the C-store architecture plays a big role in the performance result, but the paper didn't mention that. And another thing is that it seems that the performance of the MapReduce itself also depends on the system it is built. So I think it's overall a good paper, but I want to search more papers about these two systems and to know deeply about that. Thank you, that's all.